All right, my algebra class, let's go ahead and review for chapter 8 test lessons 8.1 through 8.4. I'm doing this on this PowerPoint this time because I might need a calculator, and that doesn't show up in the other one too well. So let's see how we do. We've got graph hx equals 1/4 x squared. So I'm going to get my drawing tool over here. If I do this, first thing I'm going to do is make a table for myself. If I do, I'm going to plug in x. And I think what I'm going to do is take all this and move it over here. Okay. And that means this is going to be h of x, which is like saying y. All right, now we're going to take these numbers. If I've got 1/4 x squared, and I was to make x negative, I'm going to go by, remember, factors of 4, so I'm going to start with -4 first. If I do the -4 as x, and I square it, all I did was replace this x with -4. Then -4 times -4 is 16. And I got 16 times 1/4. And 1/4 times 16 is going to give me 4. So when h is -4, when x is -4, h of x is 4. All right, let's go to -2 now. Okay, so if I take 1/4, and then I take -2, and put it to the second power, that's going to give me, let's see here, well, -2 times 2 is 4. I got 4 times 1/4, and that's 1. 1/4 of 4 is 1. Now we're going to go with 0. Well, anything times 0, right? It's going to the second power be 0, and 0 times 4, or 1/4, is still 0. Okay? And then I'm going to come over here and try 2. Well, if it's 2, it's still 2 times 2 is 4, and 4 times 1/4 is still 1. And that means 4 is going to give us a 4 as well. Okay, so if I graph this, should get a graph. Looks something like this. See, when I'm at -4, 1, 2, 3, 4. I'm at 4. So let's see, 1, 2, 3, 4. So I'm going to be over here. That'd be my first dot. And it says when I'm at -2, that would be here. I'll be at 1. So that's going to be about right here. When I'm at 0, I'm at 0. So that's going to be here. And then when I'm at 2, well, 1, 2, I'm going to be at 1. And when I'm at 4, 3, 4, that's going to put me at 4. And that means our parabola is going to go like this. All right, let's see how I did. Well, if we connect this, we see when I got -4, I got 4. When I got -2, I got 1, 0, 0, 2, 1, 4, and 4. Just like I said, when I was at -1, I was at 1. And when I was at -2, -1, I was at 1. And when I was at -4, which is over here, that put me at 4 right up here. Okay, so looks like they went in increments of 1 up here, but then increments of 2 over here. That's why their parabola looks a lot more, I guess, leaner than mine does. All right, so both graphs open up and have the same vertex, right? Let's go through all the information here. Of 0, 0, right? And then it says we've got, I don't know why I say both graphs. I'm thinking that this was, Sorry, that shouldn't have that there. It should just have the graph. It didn't ask for information. Now I don't want to get you guys all thinking that it should, but they're comparing it to x squared, okay? But that's not what this question asked you. So I took that off of there because I felt that was unfair to ask. All right. So, okay, let's get to number 2 then. Number 2 says to graph f of x. So this time I've got a negative x squared plus 25. All right, so let's go ahead and look at this one. Once again, I'll make my graph. All right, let's go with -2 first, because we have a whole number in front of our x, or actually a negative whole number, right, a negative integer. So if I do it -2, that means first off, I'm going to have -2 squared plus 25. Well, a -2 squared is 4. And now I've got -4 times or plus 25. That's going to equal 21, right? Because 25 minus 4 is 21. Let's go get it and give -1 a shot. If I give -1 it, put -1 in here, that's going to be negative 1 squared plus 25. All right. If I do this, I see that I can go ahead and, let's see, -1 times -1, well, that's 1. Now I've got a negative in front of the 1 over here, plus 25. Well, that's going to be 25 minus 1, and that's 24. All right, and then we've got 0. And if this is 0, this would be 0, and that's going to leave 25. Now let's try 1. Well, if x is 1, I'm still going to have a -1 over here, and it's still going to be 24. And that means this +2 is also going to be a 21. All right, so let's go ahead and put that on a graph. We're going to go by 5s. 5, 10, 15, 20. And when x is -2, 1, 2, it says 21. So if this is 5, 10, 15, 20, 21 would be about right here. And it says -1 and 24. So I'd be at -1. And this is actually going to go higher, right? 5, 10, 15, 20, 25. All right? So 24 is going to be about right here. And then 0 was 25. So that's going to put me here. The other side, I have the same values reflected across. So here, we're going to have 24, and over here we'll have 21. And we see we have a parabola that looks like this. All right. Is there another way we could have done this? I think so, because we could have also said that we have, let's see, negative. We could have factored out our negative, right? That would have made x squared minus 25. We remember the rule. If I have a negative, right, a -25, or a negative, a number that can be, to get the square root of, then I can say that this is really a negative times x squared, right, minus 5 squared. And this is going to turn to negative x plus 5 and x minus 5. And if that's true, then when I solve this, x would be negative 5 over here. When I solve this one, x would be 5 over here. Remember, we'll have to subtract 5 from both sides. We're putting both of these to 0. And it's probably better if I went ahead and made lasso these and move them a little bit. Here we go. I'm going to, uh-oh, I didn't lasso everything, sorry. Let me try that again. Lassoing tool can be a blessing and kind of perturbing too at times. There we go. Let's put that there, just so I can go ahead and demonstrate. For those that forgot, we put x plus 5 equals 0. Then we minus 5 from both sides, right? And that's going to give us x is equals negative 5. Over here, we would put x minus 5 equals 0. So we're going to have to add 5 to both sides. And that's how we're going to get x is 5. Okay, this tells me that x will be negative 5. So this is negative 2, negative 3, negative 4, negative 5. And over here, I'd have 3, 4, 5. And that tells me I'm going to have a coordinate here and here as well. And my parabola is going to go something like this. All right. So, yeah, very easily I could have found x, right? Because when x is 0, that would be 25. That would put me here. And then my points here and here using this, and I still would have got the same parabola. Let's see how I did. Let's see, I've got little room to actually view it, so I'm going to subtract or erase all this part over here so we can view it a lot easier. All right, so let's move this over and compare it. Well, according to this is in tens, right? And notice over here, negative 5 and 5, just like I said over here, were my x-axis. If this is 10, then this is 20, and this is 25. And we said this was 5, 10, 15, 20, 25, just like I had. Now, it might look a little different because they went by 5. Looks like they went by 2s on this one, where I went by 1s, and then they went by 5s up here. So our parabolas look a little bit different just because our scale is different, but it's exactly the same as it should be. All right, let's go ahead and get to number 3. All right, number 3 says y equals 2x, or 2 over 3 x squared minus 6x plus 5. And I guess we're still graphing, so let's go ahead and do that. If I'm graphing this, let's see here. All right, so let's go ahead and work this problem here. We did say that there were ways to find our vertex, right? Remember that we're going to use the formula negative b over 2a. Okay, so for this one, we're going to have negative 6 on top. We got a negative 6. Don't think that the negative goes away just because there's already a negative there. And then we're going to have 2/3, right? 2 times 2 over 3. Okay. So now we have a negative times a negative 6. That's going to give us a positive 6. We have 2 times 2. That's 4. So this is going to be 4 over 3. Now we have a fraction in a fraction. And to do that, we need to do keep, change, flip. So this is going to be 6 over 1. Keep the top number the same. Change the multiplication and flip the second fraction. Well, 4 and 6 can be reduced, right? So I can take, divide both of them by 4, or by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. And now I got 3 times 3. That's going to equal 9. And let's see here. Well, yeah. Let's make sure everything's right. Yeah. And that's going to be 9 over 2. Okay. So now I'm going to plug in. I found out what my axis of symmetry is. So remember, my axis of symmetry is where it goes through. And 9 over 2 is really equal to 4.5, right? 4.5. I know this because 9 divided by 2 is 4.5. So that means this is 1, 2, 3, 4, 5. That means my axis of symmetry is going to be sitting right here at 4.5. Okay, now let's go ahead and work our problem. We're going to take this 4.5, or I'm going to take 9 over 2 actually, and plug it in. So if I take 2/3 and I multiply it to 9 over 2 square. And then we're going to subtract 6 times 9 over 2. And then we're going to add 5. All right, well, 9 over 2 squared is going to be 81 over 4. Because remember, we're squaring 9 and we're squaring 2. And then we're going to multiply this to 2/3. A negative times a positive makes a negative. And let's see, I could take this and put it over 1, and then reduce 6 and 2. 2 divided by 2 is 1. 6 divided by 2 is 3. Now I just have 3 times 9, and that's 27. And then we add the 5. Okay, now we're multiplying these across, but I can reduce again, right? So this is really 2 divided by 2 will be 1, and 4 divided by 2 will be 2. Now I have 81 divided by 6. So let's put this over here, 81 over 6. And I'm going to subtract 27 and then add 5 to that. All right, so now I have to say, what is 81 divided by 6? So I know what it is as a number, right? I could say that negative 27 plus 25 equals negative 22. So why don't we write that over here? 81 over 6 is minus 22, right? Remember, we take the big number minus the small number, keep the sign of the big number. All right, when I do this, I'm going to take 81 and divide it by 6. When I do this, I'm going to get, let's see here. Well, that 6 goes into 8 one time. That gives me 21. 6 goes into 21 3 times for 18. That's going to leave me 3. And I could go ahead and put a 0 here and a decimal and realize 6 goes into 30 5 times. So it's 13.5. So now I've got 13.5 minus 22. All right, I'm going to get my calculator out. When I take 22 and I minus 13.5, I get 8.5. But don't forget, the 22, that negative, is bigger than this positive. So this would be a negative 8.5. So now we know that the, let's see, our vertex is going to be 4.5 and negative 8.5. So let's see, if this is, well, let's just put these by 2. 2, 4, 6, 8, 10. Then we'd have 2, 4, 6, 8, 10. If this is 8.5, I could say then that if this is 2, 4, 6, 8, so a little bit past 8, it's going to be sitting about right here. That's our vertex, right? Now we know that it's positive, so we know that it opens up, right? It's going to open this way. Now we have to figure out where it crosses X. Well, that's really easy because we know with this 5 here, it crosses the y-axis at 5. So if this was a negative 8.5, this would be, let's see, 2, 4, 6. It's going to cross right through here, which means when I am 4.5 away, right, then it's going to be up at 5. So when I'm 4.5 away over here, 1/2, 1.5, 2.5, 3.5, 4.5. That means right over here, parallel to my other one, should be my next coordinate. All right. Let's see. Now I can go ahead and make my parabola. Let's see. I could find the x's, couldn't I? Find the x. Remember, we found x over here, right? And that was going to be at, what's it, 4.5 is when it was the axis of symmetry. We want to find out what x coordinates are they going to equal over here. I'm really kind of fine just putting my parabola like this, and not really worrying about my x's, but if we plug them in, if we plug numbers in, then we could go ahead and find where the x is. Okay, and I'm not going to waste a lot of time with that. We're already at 22 minutes, okay? Now you see this exactly, what I did is what they did. They took the axis, or they took our axis of symmetry formula, right? They found that it was 9/2, that's 4.5, just like I did. Then over here, they went ahead and found it, plugged it in and got 27/2. Let's see, did I do something wrong here? Oh, there's 81/4. We multiplied it to 2/3, and they came up with, let's see, 27/2. Okay, oh, if we reduce 81/6, by dividing both by 3, we would have got that. Okay, and then they came up with 17/2. Is that the same as 8.5? Yeah, because 8.5 and 8.5 is 17, right? And it's a negative. So you can see right here where it crossed just a little past -8, just like ours did, right? And then it went up to 5 and crossed over 5 there, just like I put on mine. Okay, let's go to number 4. And I'm going to erase all this. I don't want you to wait for that. Let's go to number 4. Now it says graph over here. I've got, well, h of x, and it's got 1/4 times x plus 4 squared minus 2. All right, so if we're going to use this, we're going to say that we've got, okay, oh, there we go. Remember, we have these, we have this in the parentheses, right? Squared, so we know that there's going to be a little transformation there. Let's go ahead and work this problem first. If I was to take this and factor it out, okay, sorry, I had to answer the phone. We see here that we have a translation. Remember, when the number is added or subtracted inside of the parentheses, okay, we know that it's going to move forward to the left, okay, because it's the opposite. Remember, this is going to end up being, x plus 4 equals 0. So we know this is going to be a, let's see here, x, we're going to minus 4 from both sides. This is going to leave us with x is equal to -4. So now we know that this is our axis of symmetry. Remember this from lesson 8.4. Our axis of symmetry will be -4, right? Because remember, we're taking x squared, right, which normally would be here, right? This number here is just making a shrink or a stretch, so it's not going to move that. But this is going to move it, right, forward to the left. So 1, 2, 3, 4, right? And so, okay, so we have this here, and then, so that's going to make the axis of symmetry -4. Okay, and then we also notice, because they have the formula that was taught to us, I believe it was a times x, let's see, plus h, I think. I want to say plus k. I'm going to double check to make sure my letters are right. And I'm glad I checked. I did forget couple little things actually. Let's see here. This was a plus, but this was a minus, and it had to be when we're squaring the whole thing. All right, so h, I guess we should have put this as h and not x. Okay, is equal to -4, and then k is -2. So we found our axis of symmetry at -4. All right, I don't know why they call it h when it's really our x. And then, let's see, we know that we're adding this to this, and this, since it's outside the parentheses, is making it go up or down. This is going to go down too, okay? So that means it should be sitting right here, our vertex, okay? All right. All right, now that we have our vertex, and let's just write that out. Our vertex should be -4 and -2. All right, now we're going to plug in numbers into our formula, and I'm going to go by factors of 2. Since it's at -4, I'm going to try, let's see, -6, and we'll try -8 to see where they send us. So let's see, if I do -8, this would be 1/2 times -8 plus 4 square minus 2. Remember, we do parentheses first, so this is 1/2. This would be a -4, right? Yeah, -8 plus 4 is -4 square, and minus 2. We know -4 squared is really 16. Now 16 times 1/2 minus 2, and we know 1/2 times 16 is 8, and 8 minus 2 is 6. So that means positive 6. So that means when we have -8 for x, I'm going to go to positive 6. So we'll just put this up 1, 2, 3, 4, 5, 6. So that's going to put this about right over here. And now let's go with -6 instead. So now we're going to put 1/2. I want to go -6 plus 4 square minus 2. That's going to put us at 1/2 times -2 to the square minus 2. -2 squared is 4. 1/2 of 4 is 2. And 2 minus 2 is 0. So that's going to put us at, let's see, yeah, 0. That's going to be when x is -6, 4, 5, 6, and y will be 0. And now we'll just, since it's a parabola, we'll look for the other ones. 2 away from it is going to be 0, and 4 away from it is going to be 6. And our parabola should look like this. All right, let's see how I did. That was the big one. I'm going to bring it over here and move some of this stuff out of the way. There we go. Let's see, put this over here just so I can look at it a little better. All right, it says that, very good. H was -4. That's what we had over here. H is -4. The axis of symmetry is -4, it says. So that was right. We said that because H is -4, K will be -2. That's what we said over here. Good. That puts us at 4 and 2 for our axis of vertex, -4, -2. Well, look at it. When we plug -8 and plug -6 in, we're going to get 6 and 0. That's exactly what I said over here. 6 and 0, right, were our coordinates. And just so you understood that a little better, when we found 6, we were looking for y. So x was -8, and that made y 6. And over here, x was x was -6, and y ended up being 0, right? So that gave us a parabola that looked just like this, perfectly matched line. All right, let's go to that last problem now. Describe the transformation when f of x, ax squared plus c, when c is bigger than 0. Okay, c is bigger than 0. Oh boy. Well, if c is bigger than 0, it's a positive number. And if it's a positive number, that means it's going up, right? So I would say one transformation is, depending on what a is, we might have a stretch or a shrink. But since they didn't identify that and all they talked about was c, I would say we're going to be translating up however many units c is. So let's go ahead and check my answer. Is a vertical translation, c units up of this graph. Perfect. Okay, yeah, whatever c was, that's how many units up we're going. Number 6, the diagram shows the cross-section of the soup bowl, where x and y are measures of inches. Find the width and the depth. This is probably the easiest problem out of them all, because the width is going to be from this end, -4, to this end, 4. And 4 plus 4 is 8. So the width of the bowl is 8. And then the depth of the bowl, well, if it goes up to 2 on both sides, that means it has a depth of 2. That's really all there is to it. I'm hoping to write here. That would be pretty embarrassing if I got that one wrong. Oh, look at that. The soup bowl measures 4 meters wide and 2 meters deep. Whoa, 4 meters wide. How did it get 4 meters? I've got to double check this, because from what I see, it looks like 8 meters here. Let me double check this. And that was correct. It was 8 because we have 4 over here and 4 over here. Sorry about the misprint on that one before. The soup bowl is 8 meters wide and 2 meters deep. And that concludes our review for the test. Good luck, and I'll see you when I get back.